What's up guys, this is Massey. Welcome to another video. In the previous video I talked about sine theta, cosine theta, tan theta as primary trigonometric ratios, and I talked about secant theta, cosecant theta, and cotan theta as reciprocal trigonometric ratios. In this video I want to show you how to calculate them in right triangles. For example, we have a triangle like this, and we have 6 here, 8 here, and this one, using Pythagorean theorem, you can find out the hypotenuse, which is going to be 10. So if this angle is theta, we are interested to find out sine theta, cosine theta, tan theta, secant, cosecant, and cotan theta. Sine theta, as we saw in the previous video, is opposite over hypotenuse. So opposite is 6, hypotenuse is 10. Hypotenuse is always the longest side, and it is opposite to the 90 degrees, which is going to be 0.6. Cosine theta is going to be adjacent over hypotenuse, 8 over 10. You remember SOHCAHTOA, we had it last time in last video, 0.8. Next one is tangent. Tan is opposite over adjacent, which is going to be 6 divided by 8, opposite divided by adjacent. So 6 divided by 8 is going to be 0.75. Now if I want to find out secant theta, that's going to be 1 over cosine theta, which is going to be 10 over 8, or 1.25. Or if you have cosecant theta, that's 1 over sine theta. It's going to be 10 over 6, which is going to be 1.67. And we have cotan theta, which is going to be inverse of tangent. That's going to be 8 over 6, which is going to be 1.33. That's how we find out sine, cosine, tan, secant, cosecant, and cotan. Let's see another example. Assume that we have an isosceles right triangle. We have 17 and we have 17. We need to find hypotenuse first. So the question is asking, determine sine theta, cosine theta, tan theta, secant theta, cosecant theta, cotan theta. So if theta is this, that's going to be equal to this one as well. It's going to be 45. So we have c squared as the hypotenuse equals to 17 squared plus 17 squared. 17 to the power of 2 is 289 plus 289. That's going to be 578. So c is going to be square root of 578. It's going to be 24. That's the hypotenuse. Now we can say sine theta equals to opposite divided by hypotenuse. Cosine is going to be the same thing. Tan theta is opposite over adjacent, so which is going to be 1. Cosecant theta is inverse of sine. It's going to be 24 over 17. Secant theta is 24 over 17. This is going to be the same as cosecant. Like sine and cosine are the same as well. And cotan is going to be inverse of 1, which is going to be 1 as well. So these are the trigonometric ratios for this example. Let's see another example. If we have 15 here and 11 in here, what is going to be the value of c? Based on Pythagorean theorem, we can say 11 squared plus c squared equals to 15 squared. Therefore, 11 squared is 121 plus c squared equals to 15 squared. I think it's 225. Double check that. 225, yeah. Therefore, c squared is going to be 225 minus 121, which is going to be 104. And c is going to be square root of 104, which is going to be 10.2. Now, if you want to find out theta, find out sine, cosine, tan, secant, cosecant, cotan theta. So sine theta is going to be opposite over hypotenuse, which is going to be 10.2 over 15. Cosine is going to be adjacent over hypotenuse, so 11 over 15. Tan theta is going to be opposite over adjacent, which is going to be 10.2 over 11. Secant theta is inverse of cosine, which is 15 over 11. Then we have cosecant theta is going to be 15 over 10.2. And we have cotan theta is going to be 11 over 10.2. So these are the ratios for trigonometry. We can leave it like fractions, or we can write it in decimals if it's needed. So basically that's how we find out sine, cosine, tan, secant, cosecant, and cotangent for right triangles. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.